whose contributions to the fields of artificial intelligence, machine learning, and many more have been truly remarkable. It is my honor to introduce Dr. Eva Tuba ma'am, currently affiliated with Trinity University in San Antonio, USA, holds a PhD in Computer Science at Sanjidanam University. She teaches at Sanjidanam University and has a research focus on AI, machine learning, swarm intelligence algorithms, image processing, and wireless sensor networks. She has over 100 scientific publications and is an active reviewer for SCI journals and international conferences. Dr. Tuba is also a member of ACM, IEEE, IMS, and SIAM. We are honored to welcome Dr. Eva Tuba to share her insights and address us today. Please, ma'am.
Thank you for warm welcome and the nice introduction. I'm very honored to be here and to share this talk with all of you. Thank you for the organizers for organizing this great event and for inviting me and welcoming me here. So today's talk is with a little bit of focus on processing medical digital images nowadays with the use of machine learning and AI models. But this is a general tool that can be used for any kind of digital sequential data. It can be for different kinds of signals or also for different kinds of input data. So digital images in general, they revolutionized so many different areas. Before digital images, we had analog images, and analog images was hard to process them because it was a physical copy of a photo, and then you could apply some chemicals and scratch things and process your image in that way. Obviously, to go back to the original image, that was a huge process. With digital images, now we have just a matrix of numbers that you can change those numbers, apply some mathematical formula, and you will get a processed image. You will instantly see the results, and if you don't like the results, you can just go back to the original matrix of numbers and try again. So digital images, because they are easy to process, they brought so many changes in different areas. And one area is medicine. So medical images, we have medical images long ago before digital images. So, for example, X-ray images have been used for more than a century in medicine, and it was an analog copy of the image, and you could see inside of the human body. So it was very useful. So images in medicine are rather useful, and now when you go from analog to digital images, and when you add that you can process them easily, fast, relatively easy and fast, then you get like the whole new research area. What is exactly the benefit of digital images? So with medical digital images, first of all, you can get more objective analysis, because if you have a doctor examining, for example, X-ray images, that doctor could probably examine like 100 of images that day, so he's tired, the lighting is not really good. There's some people coming in and out, distracting physicians who is trying to analyze that image. So there is a really big human factor when you are analyzing medical images. By using computer-aided diagnostic systems, you get that objective tone in the analysis. Obviously, we always need confirmation for a human from a physician. That is because we have silly mistakes made by artificial intelligence. So we always want to confirm that, but we will talk about that a little bit later. So besides just faster analysis and objective analysis of the medical digital images, the advancements in technology brought more changes. For example, this was not possible 20, 30, 50 years ago. So this is a process where a patient will take a small pill that is actually a camera, and that camera will travel through the digestive tract of a patient, and physician will have a video of everything that is happening inside of the body, so they can detect exactly where and what is wrong, if anything. So this is called wireless capsule endoscopy images. So that field that is actually a camera travels for a couple of hours through your system, and it produces a video. Video is just sequence of images. That video can be 5 hours long, 10 hours long, it can be 1 hour long, and someone has to go through that video and to watch every single frame and to find if there is any bleeding, any ulcer, any anomalies, anything that should be further investigated. That requires a lot of time, and it's crucial to have computer-aided diagnostic help that will guide and mark potentially anomalies, so physician can focus just on those parts instead of watching 10 hours of videos where nothing is visible or there are no anomalies. So this is just an introduction. Why do we need medical image diagnostic or computer-aided diagnostic systems? Why the medical images, and especially digital medical digital images, are of interest? And now, as I said, we are focusing on medical images, but this is just a tool that is applicable in so many different areas. If you switch the story with medical images, satellite images of crops, of fields, if you take drone images of, I don't know, some remote areas, the story is equally applicable. We are just now focusing on medical images. Okay. So some of the examples of medical computer-aided diagnostic system is when you have brain MRI images. Usually anomalies in brain are found using MRI technology, so magnetic resonance imaging, and we produce images like this. It's basically take the image of your brain from top down, and then different anomalies are presented as different shades, different shadows, different white areas, and physicians can analyze those slices of your brain and find different diseases. So one of the methods that was done even before all this AI hype and all these recent deep learning models was simple clustering, because as I said, anomalies and also different parts of the brain, they're represented as different shades of gray, white, or black. So clustering or image segmentation is a process where we are trying to group pixels based on how similar or different they are from each other. So clustering algorithm is doing that with data, so if you consider pixels to be data, you're getting image segmentation. So one of the things that we could do with digital images, MRI, brain MRI images specifically in this case, we used clustering algorithms that was additionally optimized by swarm intelligence algorithm to find clusters in those scans. And when you find clusters, you can see if there is, for example, this here is obviously some kind of anomaly. It could be an infection or tumor or beginning of Alzheimer's disease or something like that. So when you do the clustering, it will point out positions more clear that this is where something is wrong. Check here for more details. Okay. Another example, what was done before deep learning models is we use swarm intelligence algorithms, optimizational algorithms to try to predict, to classify different medical databases for different diseases. So you have images, and from those images we extract certain features. We will extract the number of white pixels, projections on different axes. What is the roundest, what are the closed areas, what is the roundest of the objects, closed objects, or what are the frequency domain coefficients, what are some central moments of frequencies, of coefficients in frequency domain. So we extract all these different things from images, and then we put that in some classification model. So that was before deep learning, where features were extracted manually. So we had to know how exactly what physician does when they are looking for different diseases. They will look the brain MRI scan, and they will say, like, when I'm looking for Alzheimer's disease, I'm looking for parts of the brain that are slightly lightly shaded than the other parts of the brain around on MRI scan. And they're usually not of the correct shape. They are different shapes. They are not circular, or they are not ellipsoid. They are some weird shape. If they are more rounded shapes, then it's not Alzheimer's. It's probably a benign tumor or something. So we have to know what physicians is looking for and how to differentiate that disease from normal scan, and then we will try to extract features to describe those things that physician is looking for. Sometimes it's easy, like search for lighter area, that is easier. Sometimes it's more difficult. It's differently textured things, so we need to describe texture in the image, or it's some weird shape. Now, describe weird shape to a computer. So we cannot just say we want something that is, what does that mean? So that was the job before deep learning. And this paper is one example where we extracted a bunch of different things from the images, and then we try to find which of those features actually are good for the considered problem. So as I said, this is before deep learning. So in 2012, I think that yesterday we had a talk about that. So convolutional neural networks is something that started the revolution, but it's now one of the revolutionary methods in classification and in general in computer vision and image analysis. So it's a specific kind of neural network where the initial part is actually used as automatic feature extracted. So there is operation of convolution where we are taking different things from the image and then combine them together to build up and recognize different objects or classes of the image. So I'll just skip these few things to go here. So this is the example of what the features of convolutional neural networks are. So basically those first initial layers in convolutional neural networks, they will extract things like these, like some random shapes and lines and blocks, and then through layers, those shapes, dots, blocks, they will be combined into something that is more, if you can see here from these lines, you will these that you cannot really see on these slides, but this is basically eyes, ears, nose, and then you combine that and you're getting the face. So this is for a task of recognizing different objects like face versus cars versus elephants versus chairs. So you start with these small building blocks, and by different ways of combining these building blocks, you're recognizing different things. So now with these deep learning models, with convolutional neural networks in this case, we are eliminating the step where we are extracting features. That is done for us automatically, so we don't need to understand what physician does. And we actually don't care what physician does. We trust that this deep learning model will actually manage to find things that will describe different diseases, different conditions correctly. And that usually is the case. But there is a cost for that. So we are not doing feature extraction. We are not looking for roundness, for shape, for colors, textures, and other things. We just simply give the image to a convolutional neural network, and convolutional neural network will find these building blocks and combine them together to get normal tissues versus Alzheimer's disease versus tumor versus some other anomaly. So that is a good thing. We are saving our time because we are not doing feature extraction. In most of the time, we are getting better results than ever before. So regardless of the number, of the type, of the quality of the features and data set that we used before, we couldn't reach the accuracy that we now can with these convolutional neural networks. So with all the effort of really hard science of feature extracting and digital image processing, without that part, with just giving the images and with simply like piling two layers together, we are getting better results. So that all sounds like a good thing. There is a bad side of this story, which is now we don't know what is happening anymore. Which in some, you can say we don't care, we are getting good results, that is all that we care about. And that is true, but in medicine especially, people are more sensitive. You don't want to have a model that will, for example, make mistakes, like it will say that your knee is broken while you have like brain tumor. So your physician is like treating your broken knee that is not broken because that is what the AI model said, and your brain tumor is just lying there. So those are kind of the mistakes that AI models will make. They will do a better job than other models, maybe even physicians, but the mistakes they're making are just so silly and unforgivable and unnecessary. So if the physician would look your knee, they would know like, no, your knee is not broken. But AI model just for some reason, because somehow these building blocks build up to the broken knee instead of brain tumor, that is the consequence. So that is the bad side of this thing. Also, the bad side is that we do not know why this works. And that is something that we are willing to give or not, but we should know that if we use these deep learning models, we are basically having black box classification. So something is done, somehow those images are analyzed, and we are predicting that this is anomaly or not, but we don't know why. All these features, we don't have names for them. When I was talking about manual analysis, I was talking about roundness, shape, texture, color, shades, and others. So we knew exactly what we were looking for. Now we could extract that more or less easily, but we knew exactly what we are working with. Now we don't know what we are working with. We are working with blobs, dots, shapes, and things like that. So these things. We don't have name for that, but we can have thousands of those things that are together building, somehow they're building towards anomalies and diseases in different images. So this is another example of how we start with some shapes, we combine them, and then we are getting some other shapes, and then we are combining them, getting other shapes, and somehow from all these, we are getting classification that this is a car, or this is a fish, or this is an object, and so on. Okay, so now more about convolutional neural networks. So we said that they are working in most cases, as we could say, like out of the box, they are working better than non-deep learning models. You just put together a few layers of convolutional neural network and you're getting better results than before. Now, convolutional neural networks, as I said, those are special type of neural networks. Basically, the first few layers, they are layers where convolution, operation of convolution is done, and there are numerous hyperparameters that we can set in convolutional neural networks. So there are hyperparameters of regular neural networks, like number of nodes, number of layers, activation function, and other things that we can set in neural network. And then additionally, we have hyperparameters of those convolutional layers, which is size of the kernel, type of the kernel, number of output features, number of kernels, and all these other things. So convolutional neural networks, they have numerous of these hyperparameters, and usually in whatever implementation that you're using, they have some default values, and just by using default values, you're getting good results. But that is not what we're looking for when we're doing research for specific data set, for specific topic. So what we want to get the best possible results. So in order to get the best possible results, we need to find what is the optimal combination of these hyperparameters for that specific problem. And that is a hard optimizational problem. And for those hard optimizational problems, we can use different optimizational algorithms like swarm intelligence algorithms. So swarm intelligence algorithms are iterative population-based algorithms. So population of solution, in each iteration population of solution is generated, and then through exploration and exploitation operators, new generation of solution is generated, and iteratively we are looking for better and better results. So we start from random population, and then we have specific operators that will guide toward better solutions. So from that random population, we move them a little bit using those special operators, and in next iteration we expect to get better results. And iteratively we repeat that process, and hopefully at a certain point we will get good enough results. So that is really, really short swarm intelligence optimization algorithms explanation. So what we are doing in case of optimizing convolutional neural networks, we are searching for value for each of those hyperparameters that I mentioned. So one solution will be one combination of hyperparameters values. And then we want to find what is the best combination of those hyperparameters. So we generate a population of random combinations, and then we use swarm intelligence algorithms, so those operators, to generate better, to move closer toward better and better solutions in each iteration. So this graph here is actually the classification accuracy through epochs of different solutions. So we start with some combination, and this is the accuracy, and then we go through several epochs, and we are getting better and better solutions. But the point is that some solutions that initially look like really bad, like this one here, it will eventually end up as a really good solution, and vice versa. If you find some solution like this blue one again, that started like really good solution, it ended up like not really good solution. So finding the optimal combination of those hyperparameter values is really tricky problem, because something that can look like a good solution eventually can show up that it's not really good. So when you combine all of these, that is something worth of doing research on. Okay, so I will show some of the examples where we actually did hyperparameter optimization, so tuning convolutional neural networks, and specifically in some cases we just did tuning convolutional neural network just to see if that is something that we can do, and then later we applied it to specific problems, so for analyzing brain MRI images and microscopic blood images for detecting leukemia and other problems. So these are the papers where we did all these things. So the first one that I will present is bare-bone fireworks algorithm for optimizing convolutional neural network that is used for analyzing and detecting leukemia in microscopic blood images. So in this paper, we had a data set with different blood samples, and we processed that data set. So each image had only one blood cell, and we needed to detect if that is normal or abnormal blood cell. Is it normal or is it leukemia? So we did this task before without deep learning, and then now we use deep learning model, and we also use tuned deep learning model to get better results. So this is the data set that we ended up with. These are the examples of health image. It's very round. These are the things that we looked before deep learning, for roundness, for color, for saturation of the color, size of nucleus versus size of the cell. So those were the features that we tried to extract before. Now we just give this whole image and see what the results are. So these are the hyperparameters that were optimized by swarm intelligence algorithms. So we optimized convolutional, involutional layer, filter size, activation function, and pooling size. In fully connected layers, number of units and dropout probability, and learning rate was also one of the parameters that was optimized by swarm intelligence algorithm. For each hyperparameter, we had the specific values that we tried, or specific range that we looked through. And the results were compared with our previous method that didn't use swarm intelligence algorithm, that we didn't use deep learning models, and these are the results. So accuracy was 97.7% in when we used tuned convolutional neural network, and the work that we did before without tuning was and with feature extraction was 93.84%. So that is quite a drop in accuracy with just without feature extraction, but using convolutional neural network. Another example where we used tuned convolutional neural networks for medical images was detecting brain tumor, or finding the stage of brain tumor on MRI images. So again, we had a data set that I think that I have a data set of brain MRI images, slices of the brain, and the task was to classify it as normal or abnormal, or normal versus what stage of brain tumor. And you can see the details of the data set that was used. So data set was not done by us. We just had a data set with labeled data. And then we used, these are the hyperparameters. Now we have like a little bit larger, if you remember from the last slide, this is a little bit larger group of hyperparameters that we tried to optimize. We used Firefly algorithm, and specifically we adjusted that algorithm for this problem. And this is the accuracy of the model through iteration of the algorithm. So you can see that the accuracy was increased by trying to tune it more and more. So from less than 70% we went to more than 90%. So that is just saying how important it is. And this is the comparison of finding detecting tumor in those images with comparing with the different methods from literature. And as you can see, if you don't use convolutional neural networks or deep learning model, accuracy is pretty low, 62%. And you could go and find another examples where the accuracy is similar, it goes up to 65 maybe percent. But if you just use convolutional neural networks, accuracy goes to 90%. So, and then if you additionally tune it, you can get even higher accuracy. And this is the latest paper. It was accepted and published a week ago in the journal from top 2%. And it's quite interesting to mention because it's it doesn't sound like image processing in the first look because this is detecting respiratory conditions from the audio files. So physicians, when they are looking for respiratory diseases, they are using the stethoscope and they're listening to your lungs. So we just make an audio file from that. We record the sound of your breathing, of your lungs, and then that is the input to our model. So based on that file, we want to see if those are the healthy lungs or there are some disease in those lungs. If there are some anomalies. And for this problem, we actually use convolutional neural networks. And this whole talk is about digital images, but we can actually use any kind of signal. In digital images, you have those spatial correlations. So position of the pixel is important. In audio file, the position in time frame is important. But for this specific paper, what we did, I just picked the slide to go. There is a method that you can use to go from audio files to the image. So it's a simple mathematical equation that tells you take this audio signal, do these transformation in this way, and you will get the pixel value. So from audio file, you're getting now spectrogram pixels, and they look like this. So basically, we have image as an input to our model. So this is how this audio signal looks like. And then that convolutional neural network was optimized using different modified and adjusted swarm intelligence algorithms. It was additionally there are some methods that you can use to boost the accuracy. So instead of the final classification layer, you use different less accurate models, and then you combine those results and you get better results. So this paper combines a bunch of different methods that could possibly provide, so tuning your hyperparameters, combining different classification models, converting audio file into images, and all these things together managed to produce better results than anything that was done before. So this is for a task of detecting respiratory diseases based on the audio file. And now there is a lot of tables, but I will just skip to the most important one. So we compared, first task was just to see if we can differentiate healthy versus not healthy sound of the lungs. And then when that task was successfully done, it was not just healthy, not healthy, but healthy or what kind of disease. So is it bronchitis or some other disease? So these are the results for binary classification. And so these are the parameters that we obtained by our IT. These are the final results for the binary classification. So as you can see here, the accuracy is 97%, almost 98%. And now we have the same middle results, so trying to just tune the model, trying to use different classificators and all these things. So those are the mid results here. But for multi-classification problems, so when we are detecting healthy versus 3 different diseases, lung diseases, and these are the accuracies that we got at that time. So it's 77% by our model, but yeah, and that's the physical analysis that we will skip for now. So basically, these were just like 3 papers that can show how to use optimizational algorithms for tuning deep learning models for medical image analysis. But as I said, these are just tools, and we saw the very last examples is that we didn't even have the images, but we could transform that signal into images or to any other and use it for as an input to our deep learning models. So I would finish here and just say that this is a very powerful tool. This is a simple example of how to use it for medical images, but any kind of images, you can use the same tools, the same methodology, and get results better than current state of the art. So, thank you.
Any questions from the audiences? Yes.
So, how to know the lungs health if we have some data related to COPD? You said COPD, no? COPD, common pulmonary disease. COPD, common pulmonary disease. So what information required to know the health, lungs related disease, lungs health, in order to know the lungs
For the
health.
last paper?
Yeah, yeah.
Lung disease? So there is a data set audio file. So each patient was recorded and audio file was created. And then the spectrum from that audio file was created.
So
an image.
breathing information, so how to capture the breathing information.
So that data set was not collected by us. It was collected by recording spectrum of the patients. So it was recorded with. There are papers that are actually trying to record by mobile phones, but this specific database was created in labs. They just had like a special device that they would connect and read the signal.
So do you have any study on skin related data?
Skin data?
Yeah.
Yeah, there's a lot of papers that are doing like different skin diseases detection using convolutional neural networks, also generative adversarial networks and transformers. So there is a lot of data sets that you can find online for detecting skin cancer or classifying moles on the skin if they are benign or malignant. So you can use the same principle. You just need to have a data set that is labeled. And I think for skin diseases, there is a lot of data sets that you can find online.
Just to add, for any medical data, we need ethical clearance. So we computer people, we are not allowed to do any kind of examination without the help of, without the involvement of any physician. So that is why all these data sets need to be created by physicians only, and which give medical clearance, ethical clearance we need to acquire, and this need to be declared everywhere wherever we are using.
So basically those medical data sets that you can find online, they are cleared of all, so there are two parts. One part is like you need physicians to label that data set because we are not educated to do that.
Recently we have created one data set on the cervical cancer with Siliguri Government Medical College, that is called Jalpaiguri Government Medical College. It has in our Sikkim Manipal Institute of Medical Sciences. So in collaboration with this, so we have to go through all those processes. The data set has been published now, but we have to complete everything.
You have to put your own privacy data in here, identify.
Now we are working on another one that is on psychedelic data. That will take some time. So many things will be.
Okay, thank you.
Anything else is there?
Thank you so much, ma'am, for your informative and insightful session. You explained so nicely how data science and convolutional neural network is playing a vital role in diagnosis of disease and treatment specifically. And definitely it will help our faculty members and PhD scholars on their research activities. Now, I would like to request our principal, Professor Dr. Jivananda Jaina sir, to present the appreciation certificate to Dr. Ivatuba madam for his keynote speech. Please, sir. Now I would like to request our principal sir to present the certificate of appreciation to Dr. Milan Tuba sir for his keynote speech in yesterday. We are privileged to have amongst us Professor Srinivas Prasad, sir, a seasoned academician and a researcher with a distinguished career spanning over 3 decades. He earned his Bachelor of Engineering in Computer Engineering from Amravati University, Maharashtra in 1989. His academic pursuits continued with master's degree from prestigious institutions like the Indian Institute of Technology, ISM, and BITS Pilani. He further deepened his expertise by completing his PhD from Utkal University, Orissa. Professor Prasad boasts a rich and diverse experience encompassing software industry, teaching and research in both India and the USA. His research interests lie in the cutting-edge fields of software engineering, cloud computing, and data science, reflecting his commitment to advancing knowledge in these critical domains. We would like to welcome you, sir. I would like to request you to please kindly address the session. Please, sir.
Good morning, professors. Namaste. I came for actually session chair, but as request to participate to young engineers as well as those who are starting their research. Currently, I'm working as DRC head for data science and in the Geetham University, and I'm maintaining a lab for that. So my request is that from the beginning, when in the first year onwards, when you start working with Java or C language, right? Nowadays, we need to customize the code and things. You put it one or two chapters, how to generate the code from GenAI, right? And using that, the developed code by the students, how to customize and get the required output. So you should be, you cannot avoid that generating the code, right, from the GenAI or some AI tools. Nowadays, we have to practice how to create it and how to use it, because the industry needs that actually. And second, I observed that most of research, those who are pursuing their PhD, inappropriate or sometimes unavailable of identified research papers, they get the old or which is not required for their own research directions. Those type of papers they refer and they start working on it. But at the end, what happens? They never get to their required research outcome. So I request that take more time for taking your review work and collecting the good research papers, right? So that is sometimes what happens if you take a not recent good paper and you work with other paper, right? And you get some output already available in the market. So that time sometimes it is not good for research. So those parts you have to look into it. And as in that tool review, or most of the people what they are doing is they are connected with Python libraries for ML, deep learning, or whatever the algorithms they are using it. My request is that from the beginning, right, from the college level or starting your research, don't use the models or APIs available in the languages, right? Even don't copy from the net also. You start developing your own algorithms, right? That will help you at the end to be a good research. And second thing that when you talk about data sets and related things, right? Most of the times, sometimes we are not expert in that. Some of the key fields where we more apply our machine learning applications. Like most of the researchers, they work in medical field, and some people they work with agriculture, with the IoT and all. So there I request them that always say, ma'am, say that we have to involve right domain persons because we are not that much of intelligent on that field. So integration of different domain people and get the right thing, that's also important. And when you sometimes when you drop anything, right? Please like dropping some of the key attributes. Just go for that. Why you drop that? That is more important. That review we have to do. And one more thing I want to address here, like if everybody we are entering into the research with integration of AI, ML, and whatever deep learning algorithms, right? So first of all, before starting that one, you should think that why your problem needs that. Is there no any other deterministic algorithm is there to get that algorithm, that output? You have to validate it. Right? Then you go for required learning algorithms and all. That part I want to. I observe that most of the researchers, when they do, they miss it actually. So I am working in basically software engineering, bug finding. So I predict interface bugs and model-based bugs. In that direction, I work for last 1 decade. I am working on those and God also bless you all. And I hope that all you might have learned many things from many resource persons. Good day. Thank you all.
Thank you, sir. Thank you for your inspirable and insightful words. Now, I would like to request our principal, sir, to give the appreciation certificate to sir. Thank you all. We will back here our two. Now I would like to request Dr. Sudipta Bhattacharya sir for the invited speech. Please sir.
स्क्रीन ऊपर पड़ी अच्छे लाइव स्क्रीन ऊपर पड़ी
Hello. A very good morning to all of you, all the dignitaries. Myself, Dr. Bhubaneswar. So, today I just discuss about speech emotion detection for recent research field. So, what type of work can be done in this particular field? So, we discuss onto a small discussion onto it, and this discussion, it can be interactive. If you have any question regarding this, if you want to start with this work, then is it visible? Is it audible? So now, if I want to say about that speech emotion, is a very important thing nowadays. Why it is important? Because there are several types of application can be done by this particular area. Like if you say that any type of computer interaction, if you want to know the mental health and some monitoring to personalize any type of learning, you can understand from this emotion detection. Any type of application can be done very efficiently using this AI, using this emotion detection. We can do it. Okay, so let's go into the next part. So this is the one part of the deep learning for emotion recognition. Deep learning means, here I want to say in this particular slide that this deep neural network and convolution neural network can be applicable as a detection for the emotions. Okay, so now one part of this speech emotion is different types based on some linguistic approach. If the language is changed, and the emotion also be changed. Like if I talk anything in English language, so that emotion something else. If you are talking about any type of Bengali or any Korea, different types of languages, then the emotions, some sort of things are totally changed. Means that I am talking about that if my data size is changed, then and different types of problems can be arise. So we want to know about that, what type of problem we can face and how we resolve it. So this is, if you want to do work in this particular field, these are lots of challenges are there. So this is one of the approach that in deep learning for emotion recognition. And second is multimodal emotion recognition. Yes, it is very important that only speech is not enough to know the emotion. If I want to see the picture, videos and speech, then automatically I can see the what is the actual emotion. Like if I talk some figurative languages, okay, I'm saying some people are saying that I know that suppose this type of work, I'm not well, but I'm saying that sometimes we are saying that thank you for putting me hold. So thank you putting me hold is if you want to go for the only text, then it is a positive thing. Somebody says thank you me for putting me hold, but in putting me hold is not a good thing. So if my emotions by speech is saying the not enough, so then the part of language as well as text as well as my facial expressions, if it is applicable, so automatically some sort of another story can be arise from there. So human emotion is very complicated part. So this type of multimodal emotion recognition is very important for this particular field. Okay, and I'm saying over there speech analysis, facial expression analysis, and body language analysis. Okay. The next part is very important part is called cross-lingual emotion recognition. It's a one part. These are the very much challenges that sometimes we are talking in different languages. Like only if I'm saying something in our normal talking, we can talk with not only the English. We can mixing with the Oriya, mixing with the Hindi, mixing with the Bengali. So this type of approach cannot be right now. It is not understandable by the system. So if you give an instruction to the Google, So always you have to speak in English. But we are not in normal life. We are not speaking in always give the instruction to all. It is not possible for giving in always in English. Sometimes it is combination of Hindi and English in case of that. So this type of instruction, how a system can be handled. This area is not so much standard nowadays. We can work on it. So cross-lingual, another thing is that the cross-lingual, multilingual, this type of approach. Suppose your system is trained in English, and then I have to test that through the different languages. So cross-lingual approach showing the different various types of challenges, and the solution is that we can, as a training the data, different cross-lingual approach, different database has been there. We have to create the database. We have to mix in Tamil, Telugu, Oriya, English, different we are matching onto that. So we can create a database and work into it. So there is a lots of challenges for basically for the Indian people, because lots of different languages is there in our country. Okay. Next slide is. There's another thing is we can face some challenges for some noisy environment. If I'm talking in a real life, so most of the research has been done in a recording, from the recording. Okay, but this type of part, some work has been done, but not more than very good work now has been done right now in a noisy environment. So many noises there. How I can use this type of things, and how I can different this noisy environment from the original data, what I actually need. This is very important. This part can be explored. And next is individual variability. That is also important, that people express emotion differently. So that different can be, we can use it as a system from where we can recognize emotion across individual person. Basically, my emotions and any other's emotion can be changed a very small. So if my system can understand what is actual my mental health, what is actual my emotions, that is very important in this type of research segment. So and second is the cultural differences. So many times we have seen in our India, lots of culture has been different state-wise, different emotions, different activities. So these type of works can be done using this particular segment. Okay. So and this part is very important nowadays. Several types of work has been done on the ethical consideration of the speech emotion. So nowadays this type of work has been done that I can use my thoughts through Amitabh Bachchan voice. So this can be done. So, but I have to think about that. If I do this type of work, so some ethical things has to be remembered for that particular segment. So that kind of privacy concerns and some biasness, some transparency, these type of things can be explored. That how we can use these type of things. Okay. The next one is, these are the applications, and as I already told you that in the application for the mental health and customer care services. Nowadays in the customer care service there is a first level is trained by the AI. Then if that segment cannot be handled by the AI, then it is automatically called transfer to the human. So in the first slot is totally taken care by that human. If your language and if your emotion is much more in the anger issue, your emotion, that means your arousal and valence is greater than, automatically that all transferred to the human. So this type of work has been done in this customer care services and education. This is a very part. Nowadays I have seen a software that it is such a kind of the design. It's seeing your voice and they ask question after knowing your voice and your facial expression, they change their content according to that. Some sort of things, most of the cases, when we not understood anything, our facial expression has been changed. And also, if you ask question, if I am not able to ask this, able to say this answer, then automatically the content has to change accordingly. So that is very important part for the education purpose. And obviously entertainment purpose, based on this analytics, we can use in our entertainment purpose that what kind of content is useful or not. So these kind of things we can easily go into it. So these are another the future direction, as I already told, that multimodal integration, some personalized models, and explainable AI. This part is very important nowadays. We are lots of models are there, land, share. So these kind of things we have to be used for in this speech emotion detection research purpose. And as we already said for the ethical framework is if it is standard, then automatically these kind of so many things are in laws and orders we can implement it in this particular section. So these are my findings for working in the particular speech emotion detection research. So this part has to be explored. Okay. So these are the takeaways. And any question regarding this? Do you have any question? So actually, my object is that to just showing you that these kind of research are actually happening, and some sort of section is left. If you want to work with this domain, there is a lots of portions is there. You can work into it. So that is my today's lecture. Thank you all.
Multimodal speech detection is a very interesting area because people will be supposed to group of people who are talking here in a different languages, but you have to classify and you have to find out what kind of discussions are going on. If something fishy is going on or something very important is going on, so classifying those species from different languages, it's very important and it is an interesting area of research. If you are interested, if you are having some kind of questions, please ask Dr. Bhattacharya.
Anybody wants to have any question regarding this? If you want to, I also say to the students also, those who are, nowadays the projects, you can do these type of projects also. Because we have seen in my college days, when we start our work, lots of technology has been changed, So, but current scenario for your job purpose, if you represent properly your project, that sir, I am not doing only the coding, because nowadays coding is doing the English work by using your AI, you know about that. But the logic, the concept, according to, if your software is working in India, it is not working as because it is involved some people concept. And I'm saying something that ethical thing, where it is ethical in India, outside India, it is not ethical. So many things are there. It's changed by the geographical locations and different types of things can be incorporated. So this type of you have to build your thing that what actually I want to do by this project. Okay. Nowadays some software is there. Suppose I am talking, I can convert my voice into any male, female, any specialized person. Okay. So this type of work is very good, but there is some, that people can, if it is used for any another purpose, then it is a problematic, right? So you have to also think about that and how people cannot use this type of application for their own purpose. You can also stop them. So many things are there, and I suggest you that speech emotion, to handle with the speech rather image is very easy for the student also. That there is a 2D and speech is a 1D. So if you want, and there is a lots of features, I am not going into that deeper one, that feature extraction policies are there, different types of feature extraction policies are there. But suppose you are working with a linguistic, some features will work and another features will not work. It's not like that I am using this type of features for this audios and this is also work for the another project. No, it's depend upon, it's a customized things. According to your requirement, you have to check that this particular thing will work for this particular project. Okay, so I suggest you that if you want to start this type of projects, first
you have to collect the database. And the database means that is voice database. And database are two or three types of database are there. Suppose I am using the database which is recording in the studio's environment. Studio environment, you don't need to filterize anything because already it is filterized and the voice quality also very good. Okay, but if some of your friends talking with you, then these type of recordings can be used for there's a much more challenges than the previous one. First, you have to separate the noises. Then, if you identify the speaker identification. Suppose two people, three people are talking. You have to identify the three voices separately. This can be also avoided. Very small and tiny steps can be done through this. Then if you start this type of project, you can do some interesting things. And nowadays, I think that everyone participate with the SIH, this type of project, Smart India Hackathon, or this type of hackathon is going on all over in India. What they actually need, what is the proper application in our daily life. We are doing something and it is just covered in my book shelf. This is not my project report. My project report can be an application particular thing. It is an application part. So I suggest you all of you that do this type of. There is a Kaggle. You know the Kaggle is a data where you can get the mostly data. Okay. So these type of lots of databases are there for different linguistic, some conversation. Some telephonic conversation, 1 hour telephonic conversation with the two friends, some interview. So there you can separate from the particular two speakers and initially, these are the initial work for you because for the starting, if you go for the much more big thing, then you cannot handle it. So my suggestion is that nowadays from the audio you can extract the text, what he wants to say. So automatically now the subtitle is coming from the automatically, right? So this is also a project. Okay. So these type of things first you have you just start. Then you can get some interest. This is my suggestions. Okay.
Sir, I have a question.
Yeah.
How much data set we have to feed into that AI model?
See, AI model, you say that now AI model is what artificial intelligence model. Okay. So there are lots of models of that models can say. You have heard these two terms. One is a Gen AI, another is normal AI, right?
Yes, I have heard.
Okay, so there is a two parts. AI reading the data. Then from there, if you go for the classification or recommendation based on your data, AI can do this. Okay, so there is a lots of models are there. Model is not important for your work. Your important is what type of database you are handling with that. And you think that 6,000 samples, okay, 6,000 is the samples. If you think that it is enough for your trade, for your machine, it depends. Depends means that suppose my work is going through 6,000 sample for a 5 to 6 people, then it is very good. If the number of people and number of varieties change, then 6,000 is not enough.
More data.
You have to give more data. It depends what actually you want to do. And now another thing is called the features. Features is what the voice. What I want to say, I have to take the features from there. I have to say when I have to separate the noises, then I have to know that this is my features. I have to separate this. This will not work. And the second thing is that this is my actual data is working for that. So you have to use the features also particular. Word for that particular word. So depending on, suppose if you want to know the mental health of a person, that 6,000 data is not enough for that. To understanding the mental health, see, think like that. As we are a human being, what we actually want to say, can you judge one person that what is your mental health for just one day meeting? Is it possible? Similar for the system also. The data variety, if the different types of variety, different day, suppose we most of the cases for our friends, we know that this friend is a very anger issue, this friend is a very friendly. So we know about that because we passed so many years with him, because we have seen lots of data in my brain, and it just fed in my brain. Some decision, we have seen that some decision in that situation, what he says. So this kind of approach is my data I am collecting in my brain. So similar thing for the system also. And our brain is very, very much much faster than a supercomputer. Okay, so our brain also takes the it is not, you know, that this is if I say the example of that, suppose one of your friend after 10 years back you see that, but we can remember the face, right? But can we remember what he wear on that day, each and every day? What is the color of his shirt? Most of the cases, something is different. You know, some different means that our brain, most of the cases, it is take some features, value, and keep in our mind. But some sort of things. Suppose you met Sachin Tendulkar in one day, you can remember what you wear and what we can the color of the shirt, because that is we give the weightage to that particular data. Weightage is very important. We keep the data in our human brain with some weightage. That weightage is similar for the neural network to the same. It gives the different types of weightage according to what actually I need, what actually shows on my projects. Okay, this can be a speech, this can be a text, it can be a videos or images for similar things. Okay, you understood that? Yes. Okay. Any other question? Any other question? In that side, do you have a question?
No question is there.
Okay, thank you.
Thank you so much, sir, for your amazing interactive session and insightful words. Dr. Sir, to provide certificate of appreciation to Dr. Baniatangi. Please, sir. Thank you, sir. The next keynote session will be started at 1 p.m. by Dr. Aniket Mahathi. So please be seated.
मैडम से प्रियो को डाक करोगे लोग क्या करोगे साइड मोड पर साइड मोड पर
ଫଟୋଟା ସେଭ୍ କରିଥାନ୍ତି ଆଉ କଲିନି ମୁଁ ସ୍କ୍ରିନ୍ ମାରିଦିଅନ୍ତି ଫିଗର ରହୁନି ବାହାରୁ ସ୍କ୍ରିନ୍ ସଟ୍ ଏମିତି ପକେଇକି ହେଇଯାଆନ୍ତି।
डिपार्टमेंट छाड़ी स्कूल करती धोखा सेठी धोखा देली धोखा खाऊ ना केबे केबे मोर अतिके डीआईटी फैमिली बेसी ना अरे कॉन्फ्रेंस टा मत भल लगे भल पिक्चर मिलना
ଗାନ୍ଧୀ କଲେଜ ଯାଇଛୁ। ଆରେ ସେ ନିଜେ ଖାଇବାକୁ ବାଢୁଛୁ ନା ଆଉ କାହା ଖାଇବାକୁ ଦେବ? ଆରେ ମୂଷା ଖଟା ଟିକେ ପକେଇ ଦିଅ। ତୁ ଏମିତି ହଉଛୁ ରସୁଣ କେତା
डिजिटल
स्टूडियो रे
कालीर सेशन गुड़ा मार्क शीट ना ना आपको गोटे देती जोटा आप मत कहले तो ऑनलाइन है आप कहले मैंने गोटे मधुसूदन मैडम को आपको नहीं दिले जोटा मत लॉन्च स्टार्टिंग लॉन्च कौन स्टार्ट करिए मैडम स्वप्ना मैडम क्या करिए कौन कौन पहले होम कौन पूरा
এটা কোনো কঠোর এটা কোথাও বাড়িতে লাইট কখন ওটা মানে এটা অন করলে କୋଉ ଆପ୍ଲିକେସନ୍
पहिले स्वप्नावर भले स्टार्ट करो
डाउनलोड करके खाली फिनिश में କାଲିର ତ ହବନା ଆଜିର କାଲିର ଗଲେ ଷ୍ଟୁଡ଼ିଓ ଗଲେ ପଠେଇବେ ଆଜିର ଭଲ स्टॉप मारथिल तो बुलबुल
Yeah, ma'am. Shall we start?
कौन होती कनेक्ट होनी
Shall we start, ma'am? Am I audible?
Yes, ma'am. There is an issue with my system. So there's a problem on handling. So I was not being able to connect to you. Okay,
Thanks so much,
yes. Your voice is completely audible here, but probably we are not connect to you. Our anchor MC person is ready with your wire data. He was just calling you, but probably he was not able to at your end.
No, I hear nothing.
You can get what that is.
But what I can do is I can just start the presentation. It's fine. If they can hear me, I just give my presentation one way, unfortunately.
Yes, I know. It is audible and visible. Everything is okay from our end now.
Okay.
Sorry for the delay.
But then you can just type to me in the chat that I can start my presentation. And then I'll start. Because I don't see anything. I don't know how many people are sitting in front of me. There is no dots, like the other way.
Actually, we are doing it digital board, large digital board.
Okay.
Okay, so the computer too, it is transferred to some large digital board, so it's happening very good.
Okay, perfect. Thank you. So, when should I start?
Yes, now we can start.
Okay. So, I share my screen and start the presentation.
Yes. That will be good, yeah, that will be good.
Okay. Hello everyone. Can you just, I can see Samanjit you. So if you just tell me that you can see my slide, right?
Yes, it is visible.
Yeah, okay, perfect. So hello to everyone. I'm sorry that I cannot see you. I couldn't be physically there, unfortunately. It was very kind of Samanjit to invite me and my husband here to come and join the conference as a
invited speakers, and unfortunately we couldn't travel. We are here, so I'm a professor in Clinical Science, Department of Clinical Science at the University of Bergen in Norway. I'll just talk briefly about Norway and the location of Norway and everything, but currently for 1 year we are on sabbatical at IIT. So, and we are someone kindly accepted that we can go and visit in May. So if there are some students here from Sikkim, I'm always happy to meet and chat with them. Then we would be there on a visit. Okay, so now I'm going to travel because we are here due to our children, and it's with their schoolings and exams, it's a bit hard to travel in the middle of the world. Okay, so here in India, I just want to give you a context. So this is where I was born in Pune, then did most of my further education and career so far in Northern Western Europe, and now I'm here somewhere in very cold country, very north, and in Bergen. And this is the view of Bergen from the mountains. So it's extremely beautiful, extremely not densely populated, so quite the opposite of India. Extremely lowly populated, but very, very cold. So what do me and people working together with me? We are interested in using genomics and machine learning. I know that most of you are very well familiar with the machine learning part, but many of you might not be familiar with the genomics part. So I'm going to give you a bit of introduction of genomics. And we use genomics and machine learning, both these things together. So what do we mean by using these technologies for disease? It's to predict, prevent and manage the disease. Now this diagram is quite a simplistic representation of disease. How do we get to a disease state? So there are three major factors that play in the disease. It's like as we get older and older, age is a very important factor because as we get older, the risk of all diseases increases. There is a genetic factor that we have predisposition to certain diseases given our heritage, and then environmental and previous diseases we got also so I want to factors. Now I'm going to give 2 or 3 slides of just a brief introduction of what is genomics. So those people who don't have the bioinformatics or basic biology background, they might not even have thought about the human body so much. So all our body, it has the same, in our cells, in the core, there is the same material called DNA. So every cell has nearly the same DNA. And that DNA gets transcribed into a messenger RNA which makes the protein. These proteins make the functions of different cells in our body. So this is a female body I have shown because I mostly work in the female health. And these are the different organs. So all these organs have different cell types. But all these cell types contain the same DNA inside them. But they all transcribe different bits of this DNA into messenger RNA. And then they form different proteins. So probably most of you would not be aware of the genomics revolution. What happened was that in 2003, the first human genome was sequenced, and it was a big news that the President of America announced it publicly, and that project took more than 450 million. And that was back in 2009. I mean, the youngsters in the crowd, it will sound like, but that was so long ago. But older people like me, this is only 20 years ago. And it's like now it's 2024. It's more than 20 years ago. So it's in such a short time, cost of sequencing a genome, which used to be at that time 450 million, now it's something like $500. So basically, it's such a small amount of money that nearly all of us can afford to sequence our own genome. And this has been an enormous revolution in terms of the medicine. And the genomic data, just the first step in genes. So that is the DNA that is saved in nearly all cells of our body. But then the technology has evolved that we can even generate the data from all these other steps as well. And though the genome is the same in all our cells, these messenger RNA protein metabolites, all these states, they don't necessarily reflect only the genetic content, but the genetic content is there in the genes as well. but they also have the information about aging, environment, lifestyle, and so on. With just one example we used to give, so if you give someone, any one of you, your blood sample, and if you do something called Mikhailo, then that Mikhailo carries a unique signature that whether you have smoked or not. So smoking leaves such an unmistakable signature in your blood that you can lie as much as you like, but the signature stays in your body. It's quite surprising. So now I'm going to give you 3 projects, brief description of 3 projects that is going on that I've been working together with very recently. None of them is published. That's why I'm presenting. Those who want to know what work I've done that's published, please go ahead and look at my reference. The last project is much more interesting because this is the project that started now almost 5 months ago when I arrived to India on the sabbatical. I am very slowly working on the main project that I arrived on the sabbatical. But this was kind of a serendipity. Please stay with me until the end because that's where I'm going to show you very interesting data on India. Okay, so the first project is to describe the personalization, how machine learning and genomics is helping to personalize medicine. The best example of personalization is medicine. So the personalization is what is that? It's for prevention, diagnosis and treatment. We just want to group people so that treatment is targeted and not same treatment for everyone. That's the fundamental idea. And even if we call it personalized, it's never meant to be personalized as an individual. It's still just meant as stratification. That some people would get one point. Say for example, here is a below is a standard cancer treatment. So some will get an antibiotic therapy, some will get chemotherapy, some will get small molecule therapy, and then some genomics data will decide which of these pathways of therapy are we going to follow. The project here is to understand the breast cancer, identify the breast cancer stem cells. So what happens is cancer, probably those who have heard a bit or worked a bit about cancer, this is going to sound very simplistic. But those who know nothing about cancer, this is going to be a very, very preliminary introduction. So cancer is not cell types. Cancer is a tissue that is overgrown in our body, capturing the normal growth of the cells. And what cancer does is it creates its own network. So cancer has nice blood forming vessels around it so that it gets nourishment from the blood. So it forms very nice tissue structures like other normal tissues. And it has cancer cells, and in yellow what you see is this cancer stem cell. Now cancer stem cell is the sort of most problematic cell because that actually makes to metastasis and it gives recurrence or the therapy resistance. So the goal is to identify these cancer stem cells, but the problem is that they are extremely diverse and they are very hard to identify. So if you look at this bottom figure, that actually shows how these stem cells work. So the point is that cancer is heterogeneous tissue with different types of cell types. Now these stem cells, when you give the chemotherapy, these are typically the cells that are quiescent, which means that they are quiet, they are not very active in their expression. So they don't get targeted by the chemotherapy. So they stay quiet. But while getting the chemotherapy, all the other cells die. And the ones that survive through the chemotherapy, just a handful of cells, those are the potent stem cells, and then they expand and they create a tumor again. So that is the major problem in the cancer field. So what one of the students with me did was that the problem in the field is to identify the breast cancer stem cells. So there are 3 data sets we use. One is breast cancer stem cells, the third is hematopoietic stem cells. So each of these systems, it has its own niche stem cell population from which all the cells form. So for example, hematopoietic stem cells are the blood cells. So all blood cells are formed from the hematopoietic stem cells. And the third is the general data set. It contains the stem cells from many, many different tissues. To note that the breast cancer stem cell is the only stem cell data with the cancer tissue. The second and third was the data set with the normal tissue. So here is the quick machine learning output of training, validation and testing set. So I'm not going to put time now because we are running really short of time on the stem and non-stem markers. But what you can see is that the training, validation and testing one achieves a very, very decent effort value, meaning that you can actually predict the best stem cell, hepatic stem cell, or the stem cell. But these are predicted using the same data, just using the same data, test and training. And we also, if you look at the individual genes which are predicting these ones, they are very promising as well. Now, as one would expect that the general data contains hematopoietic stem cells as well, because those are blood stem cells. So the general data is sort of, you can imagine like a bigger box which contains the red, yellow, pink, blue, all colored balls. And then you are using that data to predict only red colored balls. So that one expects to predict any. So that's why the general data set, if you look at these raw curves, you will see that the general data predicts pretty well the hematopoietic stem cell data. But of course, the sad and well-known truth is that the general data does not predict the best stem cell data. If you look at the raw curves, none of our methods or even the previously published methods, they are working even worse than us. The problem here is because the stem cells from cancer, they are modified far more from the normal cells. So they are completely irreversible, so very hard to predict them. This is just an example to show you all that the field of medicine is full of real hard problems. For example, this problem, where there is a normal development, this is an easy problem to solve. But cancer is not normal development. Cancer is aberration from normal development where things go wrong. And then it's really tricky to understand the predict the systems where things are going wrong. So this is an example where things don't work so well. Now I'm going to move, to move so fast in my presentation. Now I'm moving to the second part of the presentation, where I'm going to present a case study on the woman's health. Here I'm going to use genomics data. I will present genome-wide association study. So what is genome-wide association study? Here the idea is that we want to understand this first bit, that's why I show this figure. Disease is caused by the genetic risk, age, environmental lifestyle factors all together. Okay? But Jiva tries to address only these root cause. So what genetic risk factors do we know that cause the disease? So association of genetics with disease. What is the idea here? The idea here is that we take cases. So for example, if we want to find it for diabetes, we take the cases of diabetes, you take the controls who don't have diabetes, and then you sequence, get the genome sequences of cases, get the genome sequences of control. Then at each genome location, you count whether the cases have some ATGC base more abundant than the control, and then you say, okay, those positions have the ones that are associated with the disease. And here it's typically how the one-axis plot is shown, and each of these bars is where they are associated with the disease. So the GWAS is an evaluative resource. If you see here the number of sample sizes in each GWAS study have been enormous. So these days the sample size is really huge in the GWAS study. But it's very important to note, I really like this slide because it shows the ethnicity of the population that was studied. And you can see that most of the populations are of European ancestry and very, very few studies of any other ancestry. Meanwhile, we should all be aware that 2/5 of the world population lives in Asia and African countries. So it's important that they should be highly represented, but sadly we are extremely underrepresented. Now, my own interest is female bias disorders. So there are 3 different types of disorders that are female bias. The third one is obvious ones which are female specific. But there are 2 others. One is called autoimmune disorders. These are relatively rare in the population. So many of you might not even have heard about rheumatoid arthritis and type 1 diabetes you might have heard about. But all the other disorders, they are relatively rare in the population. But the rate at which they happen from female to male are, for example, I work together with someone else on the Sjogren syndrome, and there the prevalence is almost all females. So though it happens to very few individuals worldwide, all of them, nearly all of them happen to be females. And this is the one of the groups, autoimmune disorders. And the second disorder is the mental health disorder. So eating disorders, anxiety, these are, and depression. These disorders affect disproportionately females. Well, this is something I absolutely need to cover, though it has no machine learning or nothing related to machine learning, but this is extremely important so that there is no misunderstanding. That sex and gender differences, they don't come only from the genetic origin. They also come, and quite a big portion of it comes from the cultural differences. So every culture the humanity has studied has exaggerated the gender differences. And it starts from very, very young age. We talk to the babies very differently, male and female babies. So when I say to you that these disorders are differentially manifested in the population, we don't know whether the root is purely genetic or genetics dealing with the differential behavior of the society towards women and men. So what a student of mine did was that she collected the genetic data for here is a huge number of psychiatric disorders. So those are mental health disorders. And she has marked here in the ones that are in blue, those are the ones that are male biased, and the ones that are in red, those are the ones that are female biased. And autoimmune disorders are present to you, they are nearly always female biased. Whereas psychiatric, some are male biased, some are female biased. And then of course there are reproductive disorders. These are only female because it's the reproductive system disorder that only happens to females. And then she also selected some of the other disorders which are male or female biased, which did not belong to any of the previous three categories. Now we first tried to see the population prevalence using the data from FinGen. So it's a very nice study from Finland where they have a population level data for all these disorders. And what we find is that of course the reproductive disorders, psychiatric disorders and autoimmune disorders, they cluster together. But the most interesting thing is endometriosis, irritable bowel syndrome and migraine. So endometriosis is a disorder of reproductive disorder for female. Irritable bowel syndrome, as you can imagine, is the autoimmune disorder. And migraine, the brain, the pain in the head. So these are three different categories of disorders. They are all female biased and they are all clustered together. Here you see that this cluster here. So at the population level, these three disorders, they cluster together. Then what she did was she collected the Jiva data, that is the genetic disease loci associated with all these disorders. And then we clustered the genetic correlations of these disorders as well. And there what we see is preeclampsia and gestational hypertension. These are the pregnancy disorders. So pregnant women get these disorders. They are very tightly correlated with major depressive disorders. So the depression and preeclampsia and gestational hypertension, these are completely correlated genetically. This is really previously not known. There is some literature linked there, but it's not highly studied and not highly recognized. And there is another interesting observation that came was that ADHD, so attention deficit hyperactivity disorder, this you must have heard, that the children who are just difficult to control. And these disorder is highly correlated with many of the pain disorders. This is again a finding that was confirmed from another publication. Now we see the gene overlap. We see again that the autoimmune clusters with some pregnancy complications called preeclampsia. And the last part here is that if we have protein-protein interaction network added over to this genetic network, then we can find even the novel genes that are associated with the disorder. So preeclampsia, from the Jiva study, this FYLK gene was not associated. But with the integration with some other data, we can find some novel genes associated with the disorder. Now I'm moving to the last part of the talk, the part about the prevention. So I said to you before that this work was done utterly by serendipity. After I arrived at IIT Madras, I contacted someone here in IIT Madras because I liked two of their publications. And then I got into the data. This is the data, National Family Health Survey data. Just for all of you to know, this data is completely free to download and it's an amazing resource of data. This is data collected So there have been 5 rounds, and the 4th and the 5th round, they collected data for 600,000 women and 700,000 women, and about 100,000 men. And this is very in-depth, detailed questionnaire. And what probably all Indians should be proud of is that the response rate has been absolutely staggering. 97% and 92% response rate. This is actually shocking to me because I live in Scandinavia and I'm used to Scandinavian data sets. And there I hear all the time the pride that Scandinavians show of their own community and how involved they are. And I feel a country that is so poor and so diverse can actually manage to get response rates of 97 and 92%. It's absolutely amazing. Well, sadly, the results from the data are not so amazing, but that's something we really need to see how can we work together. So what they have achieved is that taking from the poorest person to the richest person they could get access to in that cohort of very many individuals. So even if it's a detailed questionnaire for 600,000 people, they have actually managed to collect the blood pressure for 1.8 million people, which is an amazing sample of Indian population. And they collected 3 systolic blood pressure and 3 diastolic blood pressure readings. We have made sure that the quality of the data is really high, and you can see that the systolic blood pressure is highly correlated compared to the diastolic blood pressure. This is normal. This is how it's expected. The importance of blood pressure is that high blood pressure is associated with stroke, kidney disease, heart attack, atherosclerosis, blindness, and so on. And you will not further see that how sad the prevalence of blood pressure, high blood pressure is in India. So age and BMI, this is the data. From the data, you can see that age and BMI influence blood pressure independently. So on x-axis you see age here, and at the bottom on the x-axis you see BMI. So you see that this is female curve, the red one, and the blue one is the male curve. So the females start off low, but then in their mid-50s they catch up with the males, and then they have even higher blood pressure than males. So even if females start better off, they actually end up being worse off. And with BMI, what was interesting to see is that it's near linear relationship. So the higher the BMI, the more one's blood pressure is going to be. Now, this data, what happened was that in NFLS 5, there is a very interesting thing that because the COVID-19 stuff in between, so the data was collected, half of the data was collected pre-COVID-19 and half of the data was collected post-COVID-19. So what we managed to do was to see the effect of COVID-19, and what we see was surprisingly so this is the difference between blood pressure, average blood pressure. This is BMI axis and this is age axis. So the difference between 2019 and 2015 blood pressure, if you see that this color, around grayish color, then you know that there isn't much difference. If you go redder, then you know that in 2019 the blood pressure is high. So if you just take a look at 2019 to 2015 difference or 2019 to 2016 difference, you see that there is not so much red there. But post-COVID, you see that difference between 2021 and 2015 and 2021 and 2016. The redness of this plot and this plot is much higher compared to the redness in these two plots. Now, so one can really see that the blood pressure of this is like a population level blood pressure. So really COVID-19 affected everyone really badly with raise of blood pressure in the entire population. Now the sad thing we don't know is after 2021 we have no data because this is really huge amount of data. We have no data from 2022 and 2023 to see whether these blood pressure levels drop down. Like was this raised for something temporary or this is something that changed and then stayed high forever. But what we know is that we calculated the prevalence of hypertension amongst women, and you see that only 58 or 51%, so this is data from 2015-16, but it's nearly only half of the women who don't have higher blood pressure and are actually normal. And in men, it's even more depressing, that it's around 40% and 32% men who have normal blood pressure. Now the saddest part is this figure. So the prevalence, this is the top category of the hypertension. That's why the numbers are only 20% and the 15%. So this is where the doctor should start treating you for your hypertension, because it's really clinically serious problem. And of this 20% and 15% female and 20% male, what we see there in the database, because they have asked lots of questions, that nearly 15% and 8% females are not aware, and it's even larger, 15% males are not even aware that they have had high blood pressure. So in India, the biggest problem is awareness. The interesting thing is, once they are aware, it's quite amazing that more than 80% of people go to take on the treatment. So the first challenge is awareness, but the second challenge is not adhering. So 80% go to take on the treatment, but many don't adhere. So you see here the fraction that is not adhering. Now the another interesting point, we found that those who actually adhere, so those who go, they have high blood pressure, they go and adhere, seek the treatment, they adhere to the treatment, but still their blood pressure is not controlled. And we are trying to find out the reasons why this might be the case. And then of course there is a very small proportion that actually manages to control their blood pressure. I'm nearly at the end of the talk. So it's just for all of you to know that it's not the individuals who, the disease doesn't manifest from individual self-control or truthful. That's not how it works. It actually works from the social hierarchy, and there are lots of root causes of the health outcomes. So what we see in hypertension as one of the things shown here, or depression or cancer or whatever, and they actually come because of stress, lack of exercise, diet. So you cannot just tell people stop smoking, start eating healthy and exercise, because the actual problem is all these deep-rooted problems, which is racism, sexism, poverty, and in India caste. So this is an American slide, so there is no caste system, but India has a big caste problem. So now the question is, this is really to all of you, can AI or machine learning, can we do something? When I saw this picture, I thought, what a beautiful positive outlook is it, but is it ever going to be reality? Because we all have sedentary lifestyle, and it's the stationary lifestyle. Now can mobiles and our smartphones going to manage to get us into some kind of active physical activity zone? So that's something that is just to leave you all on a positive note. That's the thing that I think. And then this is just the last slide. I'm part of computational biology unit. So this is a big group. So these are all the group members of 10 group leaders. We are 10 group leaders, and it's quite an open and very hierarchy-free structure. So that's me. Thank you. Hello. Hello, shall I ask the next speaker to give a presentation?
Hello, Professor Dosi. It was a nice talk. So we have got lots many insights from this. Am I audible?
Yes, absolutely. Thank you. But do you want me to now ask Tom to start his presentation?
Yes, definitely.
Yeah.
Just a minute. So he needs to be introduced. So we are waiting to Madam.
Okay. I'll just ask him to come and sit so that then he can take over.
Hello? Hello, ma'am. Am I audible?
Hi.
Hello?
Hello, can you hear me?
Yes, her husband is from.
Yes. Yes. It's,
can
yeah, you are visible, yes, audible as well as audible. Okay.
So they wanted to start?
Just a minute, we'd like to introduce you to audience.
Okay, thank you.
Sir, we are very honored to introduce you in front of our audience. So, Dr. Tom Luke R. Michael is a professor in bioinformatics at the Computational Biology Unit and the Department of Informatics at the University of Bergen. He is also a member of the Center for Translational Research in Epidemiology and the Center for Data Science. His research focuses on causal inference and systems biology. His recent publications in the year 2024 have been focused as follows. Predicting the genetic component of gene expression using gene regulatory networks, bioinformatics advances, and the prediction of causal genes at GWAS loci with pleiotropic gene regulatory effects using sets of correlated instrumental variables. So, and there are many more of his research work. So they are as follows. Anderson agnostic radio frequency sensing integrated into 5G NR and single cell gene regulatory networks of advanced symptomatic atherosclerosis. I think I'm sorry sir if I mispronouncing it. Integration of glass neural networks and genome scale metabolic models for predicting gene essentially. So, sir, we will feel very much privileged to listen to you. So, you may start your presentation now. Thank you, sir.
Okay, thank you very much for the introduction and thank you very much for the invitation, especially Sabai for giving this nice opportunity. So, as Anika already mentioned, we would very much have loved to be here in person with you all, but unfortunately the traveling was a bit difficult at this time. I've also seen on the program that the last speaker, so I imagine you're all a bit tired from 2 days of conference and maybe a little bit of overload. So I'll try to keep it a little bit light and sort of not going too much into everything.
We are still ready, we are still same energetic.
You're still safe?
No. We are ready to hear from you.
But you still, are you seeing my presentation or Anaga's presentation?
Yes. We are waiting for your presentation only.
But do you see it on the screen or not? Because I'm sharing it.
Yes, it is visible.
Okay, so I'll continue, right?
Yeah, please continue.
And you can hear me well?
Yes. Completely.
All right. So the title for today's talk is, I call it Causal Inference in Drug Discovery. And so just to give a very brief overview of what I would like to talk about. So the first part of my talk will be about the review that I've co-wrote together with Taves here, computational biologist at the pharmaceutical company. This is about general introduction in this question of causal inference and some applications in drug discovery. And then the second part of the talk will be about an application on myocardial infarction, so that's basically heart attack. And this is work done mainly by Sean here. Sean is a postdoc working with me in Bergen. Previously also did his PhD with me at the University of Edinburgh. And then part of the more theoretical, methodological work in here was done by Ling Fei. So Ling Fei was a postdoc working with me in Edinburgh, and some years ago, and he's now assistant professor at the University of Massachusetts. Right, so nowadays if you open just any scientific journal or even just enter any general newspaper,
on hold कैसे on hold side पे रहो तो on hold मैडम वो hold है सदी हाँ
मैडम hold तो सही कंट्रोल के असली को भेजो टाइप लगे और टाइप हो जी चंदन सर असली ना लैक्टो नंदी चंदन सर
कौन बोल
मैडम के फोन नहीं कर मोबाइल चार्ज
Hello. Hello, Dr. Michael. Are you there? Okay.
Previously, another person has shared with me. It did not.
Okay. Anyway, please share once again.
My name is Chalula Saraswati. I did present before.
Hello.
Yeah, hi.
No, some species going on in this session. This paper presentation is now available.
Yeah, my PPT is already present.
No, you are not getting. Actually, in this session now only keynote speech is going on. From Dr. Tom Michael, University of Berlin, Norway. No paper presentation is available at this moment. All the sessions are already being closed.
But today I got late today, like on 14th paper ID.
Yes, it was there till 1:30 p.m. only.
But I got managed to close the paper ID.
No. It's only keynote speeches are going on after 2 o'clock.
But I got the mail to support the date. Can I present or else?
See, probably you may have disturbed the keynote speaker. So please don't share any screen right now.
Yes. But my PPT will be the
They have missed the chance. So this is not the time. This time will be there in time always. It's always missed. No discussion please on this topic, okay?
I have one paper. That to for the thing, my paper is there. Paper 100. Paper 80. It's not. My paper will publish, right?
See, I'm learning this of later because we are waiting for the. Okay, thank you.
Hey, Anshuman sir.